Hello, fellow data science enthusiasts. Welcome to another riveting episode of the Data Career Podcast. As always, we bring to you deep conversations with some of the brightest young minds in the field of data science, providing you with actionable insight to scale your career to the next level. In today's episode, it was a pleasure to sit down with the talented Tambe Tabitha, who is a data analyst at Social Finance in their London-based office. Our conversation is divided into two parts. First, we talk about her journey into the field of data science, and we explore a highly impactful project that Tabitha worked on, building a validator tool for look after children. You won't want to miss the detailed discussion of this project. In the second part of the episode, we shift gear and focus on the invaluable lessons that Tabitha has learned from her short but impressive career thus far. As always, thank you for joining us. Now, let's query on. Welcome to the show, Tabitha.
Thank you. It's nice to meet you, Amma. Good morning.
Yeah, it's really a pleasure to have you, Tabitha. And for a long time, we've been planning to do this show, and it's finally happening now. I'm so grateful for you to taking this time to join us for this conversation. So we always like to start our conversation with knowing how, you got into the field and what are the kind of things that motivated you to join, the world of computer science, either as a data specialist, which you are, but your title, as you earlier mentioned in a previous conversation, as a data analyst. So how did you get into this field?
I stumbled into the world of data science, actually. When I was in high school, I didn't know what data science meant. I didn't know that a field like that existed. And I went on to register for a degree in electrical and electronic engineering from the University of Buea, or in the University of Buea. Buea is a town in the southwest region of Cameroon. And then during the time that I was there, I got a number of friends who were computer programmers, participated in the community activities. It has a very vibrant tech community called the Silicon Mountain Community. And then as I learned how to code, first of all in C, then in Python, I went through like this phase where I was like clicking links and applying to everything. And someone sent a link to a scholarship where they would pay for you to do an online course. And I went through the various parts that that were available in the scholarship. And you had like web development had prerequisites. You have to know HTML and CSS first. You had deep learning had prerequisites. And then I came to data science and it had no prerequisites. So I was like, okay, I'll take this one. And that was also influenced by I had this friend who was talking about data science. So it seemed familiar and I was like, okay, I'll give this a try. So that is how I came in contact with data science for the first time. And since then, I've completed a number of data camp certificates, went on to complete an Udacity certificate, and later on decided to pursue this as a full-time career.
Wow, that's very interesting. And some of these resources you just mentioned, obviously when we come to that, we'd like that you share some of these resources so that our listeners can benefit from that. But for those who may not know about your current role at Social Finance and the company itself, can you please give a context of what Social Finance is all about and the kind of works you do to achieve the vision of Social Finance?
Okay, so at Social Finance, it's a not-for-profit that designs, funds, and scales better solutions to complex social problems. That means that we work on a range of social issues, ranging from how do you solve loneliness for older people, how do we prevent our younger children from being excluded from school, so from being dismissed from school, because we found that people that are dismissed from school at some point in their life tend to have really bad outcomes. Problems from how do we improve the experiences of children in the social care sector, that's children that are being looked after by the government. So it's a range of things that we work across. And I work in the data and digital team, which is focused on harnessing data and digital to improve people and community. So sometimes this means decentralizing decision making or inviting new stakeholders into the decision making process. Like we have platforms that enable children in care to participate in the decisions that are being made about their life after care. So for context, care is children are taken care of by the government until they are 18 years old or until a certain age, and then they are taken out of the care system. So they grow up and they're expected to be independent. So we have like creating platforms to bring them into that process so they don't just fall off a cliff at the end of their care. But so far I have worked on a number of projects in the children's social care sector, increasing the efficiency of workers that work with these children, so that they have more time to spend with the children and less time is spent on admin tasks. So that's what I do. That's what we do, in a high level. And as a data analyst, I would say, so data analyst, data specialist, that means that I don't create analysis. So I would just, because people tend to hear data analyst and think that I'm creating visualizations and getting insight from data. But I was pleasantly surprised to come and find out that it was a building role. So if you would see from my examples, I'm like, building data tools, building platforms that are launched from the user. So going from that 0 to 1, from, okay, nothing exists. How can we make something exist that is useful to the users? So yeah, that's what I do.
Wow, that's really interesting. I mean, like, obviously, I mean, most of the time when you hear the name data analyst, what comes to your mind? I mean, it's more of the analytical part, but yours is more of the builder, and it's pretty strange. I mean, but was that a surprise to you? And let me say, when you transitioned from, let me say, like your expectations to what was actually required on the job, what some of the challenges you faced and how do you adapt to it? Because I mean, like coming with the mindset of an analyst mindset, and you did more of, let me say, like the data analyst, as you mentioned earlier. I mean, for the certifications which you did, the web development had prerequisites, and the other track which you spoke about also had prerequisites, but you choose data science because there's no prerequisites. So when there was this mismatch between, let me say, like the expectation and what was required, what are the challenges you face and how do you overcome this?
Yeah, it was I joined the company when we were transitioning. So it was a surprise, as you would say. Because what happened is when the job was advertised, the company was actually doing analysis at that point. So if you would look, we did this analysis on exclusions from school, how to predict exclusions from school, and the factors that affect that. So it was a largely analysis-driven team. And then when I joined, that's when the team, not because I joined, of course, but around the time that I joined, the team was beginning to move into not just producing a snapshot of how things are, but creating tools and enabling continuous analysis to happen. So we said that we don't just want to come in as temporary people and say that, okay, this is how the system is right now, but we want to enable the actors in those systems to do analysis for themselves every day. So you would see that a number of my projects, like the talk I had in PyData, was like validator tools, because we want these people to have access to trustworthy data every day so that they can do analysis and they can get insight from that analysis that they can act on. And for the challenges faced, now you'd say, I've always wanted to build. So as I said, it was a pleasant surprise because like that kind of, you're a data analyst and when I was training, I was training with like data science in mind. So I hadn't zoomed in on, I wanted to do analysis, but I got like a broad range introduction to machine learning, introduction to visualization, some really strong, pandas, NumPy, skills. All those things that you study when you've not like, focused your attention, which is something that we will talk about later, about focus and attention. But then it comes with you're seeing not just the data science skills. So I still use a lot of pandas, but then you're in a full software development project, and that comes with a number of things you have to think about: version control, modularizing your code, thinking of architecture, thinking of maintainability, all of those kind of things, documentation. It has been a steep learning curve, because just that with the Python and then having to understand also what happens in the front end. So I've been picking up a bit of HTML and CSS, but I would also have to say, like, hats off to the level of mentorship that we have at Social Finance, because if I look back at the amount of work that the range of tasks that I've been exposed to, at every point you would approximately say that there was someone senior that had oversight on that work. And so I think right now I have, like, on my projects, I'm working on the back end, but then you have like the architect, you have the CTO, then you have the whole team. We work in a very, I wouldn't say decentralized format, but you have access to every developer on the team. So it has been a really great mentorship experience that has evened out the difficulties faced. So yeah, I'm full for it.
Well, that's really nice, and it's really interesting that, I mean, you have that level of, I would say, care from your senior colleagues that are able to guide you through these projects, because in some companies, maybe sometimes you don't have that, and it's really great you're having a good time. But at the same time, like I mentioned earlier, so that's like one leg in software engineering and one leg in data science, right? And at the same time, both fields are like very large, like they're like a blue ocean, right? So like, how do you keep, let me say, update with the new things which are coming up in terms of frameworks, and also learning, and also at the same time being productive, because like you have to be learning in two, I would say, fields that are not like parallel to each other, but to an extent don't touch. So how do you actually keep up with this, and how do you learn better?
Yeah, it's by default, I'm someone that enjoys learning. So I want to, if I see like a new framework or I see like a new language, I think that I should get a textbook and like learn it from basics. So I am learning here to do things and figure it out as you go, which is very useful because there's such a broad range of things that you have to learn. Like there's changing, there's the structure of the projects from one project to another changes. And if I have to read the textbook every time I come in contact with a new skill, that's going to be very overwhelming. So that's like when I joined, I had like this list of things I have to learn, list of books I have to read. I'm still very keen about reading books, but I would say I found it very useful to just be like, what is it that I want to know now? And what do I have to learn to be able to do this thing that has to be done now? And I have to constantly remind myself because sometimes I'll go online and I'll be like, okay, go and read the introduction, go and do the tutorial first, go and learn all these other things before you actually get to the place that you want to go. And it's a continuous learning process where I have to say that, okay, what is it that you want to know? What is it that has to be done? And can you learn the thing that has to be done? And it's true that it's quite interesting, I would say. It's challenging, but it's also quite interesting. Because at first, when you're coming from school, you're used to learning all the material before you have an exam where it's like tested. But like when working, you are not tested every day, but you have to use the knowledge every day. You don't accumulate it until an exam. So I find it useful to not just say that, okay, how do you, like, for example, if when I'm learning JavaScript, I wouldn't just Google like, how do you reverse list in JavaScript, or how do you do this, and then you just like look at the code on Stack Overflow and then just like paste that same thing or write that same thing. It's important that if you understand the little bits and pieces of the thing that you just Googled, the bits and pieces add up over time, because like in 5 or 6 months you start Googling less. You start finding out that, that's why, like, if you understand why this particular piece of code works in the way that it does, then you understand why this other bit of code works in the way that it does. Things begin to come together. Like, you don't notice when they do, but you suddenly realize that, I'm thinking, especially when it comes to building tools, like there's a whole lot of processes that goes through as I write my lines of code, as I think about how do I not repeat myself? How do I make sure that another developer can pick up this code and maintain it? Like, so there's just, it becomes like second nature in you. So I would say if anyone wants to do something like this, stand at the boundaries of software engineering and data science, because most times if you do it, you're coming from one of them. So I came from data science and I'm coming to stand at that boundary. Some people come from software engineering, come and stand at the boundary of software engineering and data science. I would say, like, take every day as it comes and try to push a little bit more, but not too much. So create a tempo of learning where it's true that you would learn the thing that you need to do, but learn why it is done in that way, and the pieces add up as time goes. Yeah.
Oh, that's really interesting. And just talking about, let me say, being at this causeway between software engineering and data science, like, it's something really interesting because I mean, most of the people I talk to at my uni are also like in between. I don't know if I want to be a builder, I want to be an analyst, more oriented role. And anyway, for me, I know I just want to be a builder, and I really enjoy building things just as much as I should do. But I really want to know, like, what kind of resources do you learn best from? Is it like by reading? Is it by watching videos? Or is it like, let me say, a bottom-up approach where you actually learn the basics and you build on it? Or you need to actually, let me say, from a top-down approach where you actually need to see as you said, the why and how it happens, or a project you're working on, where the two, or let me say, like, the coding paradigm fits in. So which way, does your thought process go into this kind of decisions?
I learn better by reading.
Okay.
And it's interesting because I didn't notice it. So, like, people around me, like my elder sister noticed it before I did. Like, I thought that I could learn from any resource, but you know, when people are able to look at you more than you can see yourself. So I learn better by reading. But then I find that if it's for a new programming language, I prefer interactive mode. So I tend to have, like, the way DataCamp structures things, where you learn a bit, then you do an exercise, and right there and then you can find out whether your answer is right or wrong. Yes, I like that. But I also use that when I'm learning, like, reading a Python book. I have my terminal open, or I have a Jupyter notebook open, so that when the author says that when you run this is the output that it produces, I also run it and check whether that's the output it produces. And then sometimes I tweak things. But yeah, I think I learn better by reading. But as you would see, I want to develop that range. So it's something that I want to be able to, like, do and figure it out as I go. But in the long run, so even if I do things and figure them out as I go, in the long run, I enjoy being able to break a system apart and put it back together. I like to have those roots in the ground to understand why things are done in a particular way and how else they could be done and why they weren't done in that way. That's why I really enjoy having the opportunity to work with, like, the quality of engineers that I'm working with now, because I can always ask the questions of, like, why is it done like this and not like that? Yeah. And I think it's did I tell you that I did? So when I was in school, I was doing part-time teaching. When I was in school in university. So I was doing part-time teaching to help prepare students for the engineering exam. So in Cameroon, all engineering schools have to be entered into by, like, a national exam. So the Faculty of Engineering and Technology had, like, a national exam. We call it a concours in Cameroon. So during most of my years at university, I was teaching high school students that wanted to be engineers, so preparing them for this exam. And the thing about teaching high school students, okay, they were not in high school anymore, but they were just from high school. The thing about teaching people that are that curious and that inquisitive is that you have to know why you say the things that you say, because they would ask you why. And that is, like, that kind of shapes how I think now, because every time I learn something, I imagine myself teaching it to someone. I imagine myself, and I imagine the person piecing taking my argument and breaking it apart, and me having to justify, like, why I have done certain things. So sometimes if you even read through my code, sometimes I would actually write that, okay, this method was used instead of this other obvious method because that obvious method has this shortcoming. So yeah, that kind of, it was an interesting experience. That every day I walked into class, I had to have like a backing for whatever I was going to teach, because I enjoy teaching the students, but then they draw the juice out of you. Like, you have to know your stuff to teach high school students. Yeah.
That's really beautiful, and I really like the fact that you really have this way of, let me say, expressing your ideas clearly and documenting, because sometimes when you work with colleagues or collaborate with people and their code is not well documented and things are not well explained, it becomes a mess of what's working. And so I think it's also a nice segue into my next question based on your experience on teaching and, let me say, transferring knowledge and also working with different people from various backgrounds, which is about you working at social finance in the team which you are. And I also believe you also have a lot of stakeholders you have to report to and work with. I don't know if it's internally or externally, how you put the reporting at social finance, but it's really interesting to know how do you actually, let me say, collaborate with non-technical stakeholders and also within the team to ensure everyone is on the same page.
It's communication is it's a skill that we have to continuously learn. And it's something that I'm learning, like, from as I go through life, is that if you say something and the person you're talking to doesn't understand, then you should find a way to say it better. So you have to have that responsibility on yourself to be like, it's not that the person cannot understand me. It's that there's an easier, more straightforward way of me saying it that I have not said yet. So taking on that responsibility improves your ability to communicate in general. And with talking with non-technical stakeholders, I found it very useful to know what motivates people and what are they interested in. Are they interested in the product launch? Are they interested in, because for us, we've been building my three projects, but 2 out of the 3 projects I just did, we had to work with a community of analysts. So the target users of the tool, some of them volunteered to build the tool with us. And we wanted that to happen because we don't want to be the people that own this tool forever. We wanted to build it, but we wanted them to be able to maintain their tool when we get there. So what happens is that that brings in technical communication with non-technical stakeholders, because when they start, they don't know how to code, and then they learn how to code along with us. So explaining the decisions you make about the tool is one thing. I found it quite useful to draw diagrams. So my repositories, not my repositories, like the repositories I've worked on, you would see like diagrams of how the various parts interact with each other. So you would see that, okay, if you come to this repo, you open this file, this is how the data flows in, like from this place, this is how the data enters. It is the ingress processes are here. This is where the data is processed. This is where the validation rules are run on the data. This is where this happens. This is where that happens. And then, so I draw like a full diagram telling you what happens in the various files, just how the data flows. Because I think that if you can draw how the data flows through a tool, you can kind of give a high level view of how the tool works. But like if someone also wants to repair something, so that is like communication, technical communication with less technical partners. Yeah. So if someone wants to fix something, then the person knows that, okay, in this diagram, this process happens in this file. So you just go directly to the file. And then with non-technical conversations now, where you're talking with the person who is leading the project and the external clients, I found it useful to know what is important to this person. Is it how, because with the previous projects, it was important to the stakeholders that the analysts are learning. So the people we were building with. So I would find it that, okay, it was important to them that the analysts are learning. So I would emphasize on the progress that the analysts are making and actually produce data points, and be like, okay, these are these are the stand-ups that we're having. These are the ceremonies and that we're having to ensure that the learning is going on as planned. You can see the pull requests that they're making here, like just points to actual things, because I try not to I try to point to data points. I try to point to tangible things. I try to point to milestones. So with a client, in my head, I know that we are building this project. By this day, we should have done this in order for the project to be on track. Yeah. So I try to like clearly spell out to the client so that from their end, they can see that, okay, this feature should be built by this day, so that they have an exact thing to check in with me and to know that the project is on track. Because if they are not very familiar with how software is being built, they might not know if I'm just saying that, oh, everything is on track. They might not know if things are going out of hand, or so I try to create those milestones for them. In some case, try to describe exactly what it is that they should be looking forward to, and then work towards those things so that they have like a way of tracking the progress of the projects. And yeah, it's useful to just have like those initial meetings. Yeah. You can ask a direct question, or you could just listen to their conversations and carve out what's important to this person. And when you do your reporting, you report according to what is important to this person, what is their baseline. So yeah.
Okay. No, sorry. I mean, I don't mean to interrupt you. You can go on, please.
No. I just wanted to talk about like the various formats of doing that. So you have like text, like you could like sometimes we have stand-ups on Slack, where you just like write Slack messages of this is what I'm doing now. But I found it useful to not just say that I'm building this feature or I'm fixing this. I'm fixing this functionality, but to say that I'm fixing the functionality that enables the user to do this, so that it's because I can say that I am fixing I'm bringing the validation rules together. So the validation rules we created had like different structures, and then I had to bring them into one reporting, into one structure so that we could send them to the front end. So when I'm saying that in stand-up, of course, I would have to say it in a way that the senior engineering leadership understands what I'm working on. But at the same time, in that channel, you have like the clients. So I want the client to know, okay, what does this mean for the progress of the project? So you have like text. I also enjoy creating PowerPoints to summarize, especially if I have to hand over a whole chunk of information. Sometimes the information is spread across maybe Miro and Trello, and I just create like a PowerPoint to be like, this is where you find this. This is where you find that if you're looking for this. Then you have like the diagrams that we create and we put on the repo. Then you have comments in the code. I think that documentation should be as close to code as possible. So you have comments in the code, but you have larger documentation, like the README of the file. But yeah, if there's anything that is important to the project, write it down somewhere. Yeah, essentially, such that even the things that you don't think, because clients evolve. So if right now you're not giving the full deep technical picture because it's a less technical client, that full technical knowledge should still be documented somewhere, so that if they get someone else to work on the project later on, or if they gain more technical depth later on, they're able to come back to your project and then trace and see that, okay, this is what was happening, this is how it was being built, this is how we maintain it. Yeah.
Oh, that was really a great one, and you really elaborate on so many examples, which was really nice. But I think we're still going to dive more into that, because one of the things which I also got to learn about you was, your talk at PyData, which was about PyData London, which is about Powered Idea, exactly. So that was an interesting project that caught my eye because of the impact it had. And so I'm going to, like to know about what was the project about and the importance of it. And just walk us through from ideation, implementation, and the tech stack you use.
Okay, so the project where we used Pyrodite, so to be clear, we didn't create Pyrodite, we used it. Okay. So the project where we used Pyrodite was creating a validator for looked after children, for the looked after children data set. So looked after children are children that are in the care of the government for a period of more than 24 hours. And what happens is that there are hundreds or thousands. The UK has the United Kingdom, that's England, not the United Kingdom. England has 80,000 children in care, or approximately 80,000 children in care. And these children are continuously coming into care, going out of care, being moved around within the care system. So sometimes they're in foster placement, sometimes they're in residential placement, sometimes they're in supported. And there are various placements and there are various reasons to put these children there. And those have various implications on the well-being of the children and the budgets of the local authorities in charge of those children. So there's just a whole lot of things to model. How many children do we expect next year? Would the numbers drop? Would the numbers drop or would the numbers increase? Should we build more houses to house the demand of children? Should we sell the houses we have? There's just a whole lot of decisions to be made day to day, week by week. Some of these decisions are far-reaching and highly impactful. And you would think that the best way to make such decisions is to get insight from the data about these children. So in a very good way, there's detailed, quite granular data about every child in care. That's because there's government policy that requires that local authorities get some data points, so get some information about each child in their care and report it to the central government every year. So there's that enforcement feedback loop. So the data exists, but the experiences of children in care are not optimal yet, and children who leave care tend to have really bad outcomes. But the authorities in this space are not fully equipped to deal with the day-to-day challenges of taking care of these 80,000 children, because the data is not trustworthy. So you cannot trust that what the data says is happening is actually happening. And that's because there's a lot of human error in this data. There's a lot of discrepancies that have to be picked out, that would mean that the insights from the data cannot be trusted. So, for example, in data science, we know of null values, missing values, things like that. But in this space, we have things like a child. So supported placements are for older children that are reaching independence, so 16 to 18-year-olds. So if you see a child and you calculate from their date of birth, it shows that in this collection year, this child was 15 years old, or this child was 12 years old. Then the child cannot be recorded as being put in a supported placement. So what will happen is you would have to say that, okay, there's a problem here. There's either a problem with the child's date of birth, or there's a problem with the placement that has been recorded for the child. So the person that spots that is the person on the computer, the children's social care analyst. And that's not the person that puts in the data. So the person will have to call or contact the worker, the social care worker who is on the field, and say, this child, can you check again what happened? The data point is not consistent. Except that it's not just one rule that they're checking. There are close to 300 rules that have to be checked. So you have 80,000 children, close to 300 rules that determine the integrity of the data. So of course, that this is not something that a human being can do every day. Take every child's file and check that, okay, is this correct? Is this correct? The way these data points interact with each other, is that how it's supposed to be? So we need some sort of an automated process. But what happens is they don't have access to an automated process to check this data 9 months out of 12. That's because the only automated platform that they have is the government portal that opens once a year. So we started by, how do we improve the experiences of children in care? Of course, we want to look at the data, but then the data was not trustworthy. So we said, how do we enable trustworthy data to be available every day? That's where the validators came. The idea of, what if you can build a validator? What if you can code these 300 rules into a validator and then release it for free, so that these local authorities can run their data through it day by day and be able to say that, okay, this trend that I'm spotting from this clean data is actually a trend that I can trust. And if there's a spike in 12 to 14 years olds, then it's an actual spike and we should probably do something about it this week. But then, it's an interesting problem to solve. And you would think that creating a validator makes everything go away. Except that when we wanted to give this tool to the users, we came across an interesting problem. To scale a digital tool across the UK involves, in fact, to scale a tool or to publish a tool for users to use, means that the tool and the data, so the code and the data have to be in the same place at some point. But interestingly enough, these local authorities have independent IT departments. So every IT department is independent of the other one. So no one makes decisions for the other. And they have these IT restrictions such that if you want to install a new tool, we would have to go through all the 151 local authorities to get permission to install that tool. And we are getting permission to install the tool just in that format. Such that if we do a new release, if we do feature changes, we'll have to go through the 151 again. And we didn't want to spend all that time doing admin. We wanted to build the tool and create value as soon as possible. So the other option was, okay, what if we release it on the internet and they can just access it on the link and they upload their data? Then you have now the information governance blockers, because that is child level data. I mean, it shows you the locations of these children, the ages, the gender, the date of birth, the parents they have. Like it's if you see a child's record, you can recognize the child. That is extremely personal data. And in the UK, we have GDPR. So you cannot tell them that, okay, upload it to my tool on the internet. Interestingly, so we were faced with this interesting problem where users cannot install the tool. Users cannot use it. We cannot also just put the tool like to run on servers on the internet. They cannot just upload their data to be run on the internet. So how do we enable this tool to be launched once and for all, like the way the internet enables things to be launched once for everybody, so that everybody has access to it at the same time, but without requiring users to install the tool and still without requiring data to be uploaded to the internet? Okay, that's one challenge on its own. And then now coming to programming languages. We wanted to build the tool in Python because the whole idea was that we would give the analyst this tool to maintain. And Python just exploded in popularity among the local authorities. Its reputation went ahead of it. So a number of people were learning Python. A number of people were knowing about Python as a programming language, and that it would be good for analysis, because analysis in the local authorities is typically being done in Excel. So we said, okay, in the data science world, Python is also quite useful, quite popular, quite equipped for data analysis. So it's a good idea to build a tool, an analysis tool in Python, because we started with validating the data, and those validation rules are largely coded in Python and pandas. Started with validating the data, but the whole idea was that when they have this clean data, they would be able to build like an analysis layer on it, and that's the part of the project that we are looking forward to now, but I can get to that later. So Python has to be what the tool is built on, because we wanted these analysts to be able to maintain it, and that's the language they knew. At the same time, we didn't want to sacrifice the user interface. So we didn't want to, we wanted to build in JavaScript, because JavaScript is like the web language. Like if you want to build things for the web, you want to have like the broad range of possibilities as far as web interfaces, web user interfaces are concerned. JavaScript is a pretty good idea. So how do we get Python to run in JavaScript in the browser? And we came across Pyodide. Like it was like a eureka moment for us. Because Pyodide allows Python to be run in the browser. So Pyodide allows JavaScript to run Python in the browser in some sort of sandbox environment, such that any data uploaded into that web instance doesn't leave the user's computer. So it's run, essentially the users are able to, the way the tool works now. So you can see the tool on 903 as in 903. So 903.datatoinsight.org. So if you actually go to that website, what happens is initially they'll tell you that Python scripts are loading. And when those Python scripts load, you're able to go offline and upload your data and run the tool, and it works. So that was like, oh wow, we finally have a way to enable users to access this tool without needing to install and without the risk of their data reaching, without the risk of their data being uploaded to the internet and breaching GDPR. And it was a spark. Like from there, we've built a validator for looked after children data, for the looked after children data set. We've built a validator. We just finished building a validator for the children in need data set. We've launched a forecasting model for children placements. So it's just enabling a lot of things that we just did and didn't know how to scale. It has just been like, oh, we finally have a way to scale large scale analysis of sensitive data. So yeah, it has been really interesting joining the team just when this was beginning to happen.
Yeah, I can really, hear the excitement in your voice. And you're talking about Python. Yeah, I can imagine, because, one thing led to the other and so much learning within these projects that have gone to build another and build on the other and so on and so forth. And you're talking about Python and JavaScript, and Python most of the time we always talk about data science. It's like, I know, like what comes to mind is like Python. And it's something interesting because even recently when I was like looking at R Studio, what is used to develop R, and I realized like a lot of, let me say, good frameworks in R like ggplot, which is used for visualization, and some other libraries also in R also like trying to adapt to Python because like, it's true that R has a lot of statistical tools, but you see this Python is, just like the snake, it's a little bit kind of, I would say, it can go into any domain, like, into web development, into data science, I think it was a good choice you guys did. And
it's a very useful tool, actually.
Yeah, exactly. And just to talk about, still on the tech stack and building tools, which you guys built the validator tools. So I'd like to know, are there some interesting problems or that you've experienced that you feel like maybe there's a tool lacking for these? Because as a data specialist, which you are working with, the data side of things and the builder side of things, right? So do you feel like in this space, is there a problem that you feel like hasn't been solved, or is there a particular tool you wish existed that you would build? Also with the emerging of AI, do you feel like these are things you can like also just like apply to some of these problems you face? So I don't know what you've experienced and the kind of solution you're thinking about, but just to give a tip, is there anyone that comes to mind?
I'm really enjoying boring AI, like boring as in boring. Like, of course, we would want the shiny stuff. I'm a big fan of cars, and you would want like super fast cars that can drive for you. And I'm really fascinated about that too. At the same time, I like to take the step back and wants to include. I see AI as a tool to increase efficiency. So if we can just go back to these government processes, just go back to these people that are working in the necessary vocations. Okay, all vocations are quite important, but you have like hospitals, like nurses and doctors. You have these people that are working in the public sector, the children's social care workers, and sometimes it hits me how much work just goes into filling documentation and finding information. And I think that if we can bring these new tools, whether it be AI or anything else, but if you can bring in these new tools such that the human mind no longer has to do repetitive tasks, then that would be a really good thing. So existing processes, just smoothing them out such that I think that the human brain is a creative brain, and I really enjoy when the human brain is used to think and to do things that haven't been done before, and to combine pieces of information that no one has thought to combine. But as far as we figured out how to do something, then we can leave it up to the machines. Let them do like the boring stuff. Let's move on to like the more fun stuff. So I'm really enjoying these projects where we are going into sectors and seeing that, okay, this is how these people work. These are their processes. These are their user journeys. How can we create a tool that makes their lives easier? Can we bring data together so that these departments can spot more interesting trends? Can we bring data together so that a social worker doesn't have to spend 2 hours finding information about a child and can just like bring it up in 15 minutes or less? So there's another project like that we worked in, that we've worked on in social finance, the family context tool. So it's like, I think that I don't know if it's old age per se, or it's just a phase that I'm going through, but I'm as fascinated I'm as fascinated about improving existing processes as I am about new shiny things. So yeah, it's like, I really don't want anybody to have to sit on a computer doing something for 2 hours, 3 hours that can be automated. So I'm really keen, like even in my day-to-day work, like whenever I spot a repetitive task, I'm like, oh, I should probably write a program to do this, because I'm increasingly developing low tolerance to repeating myself over and over again. So as I step through life.
Thank you for joining us for the 45-minute conversation with Tabitha. And if you like the show, please leave us a 5-star review, and please follow up with the second part of the conversation where we explore Tabitha's journey and also some advice to scale your career to the next level. See you soon.